Next, we will discuss about acid-base titration. So titration is basically a method where we would like to determine a concentration of a sample by using addition or reaction of another compound that we know the concentration for sure. Normally, if we have something that we would like to know the concentration, say we have an acid of unknown concentration, we will place it in a beaker like this. Then after that, we will add up just a small volume, so drop by drop. And in this case, if we have an acid over here, we call also this the analyte. Up here, we will have the base. And normally, we should know the concentration of the base up to like 4 digits behind the decimal separator. And in this case, the base, we can call this as the standard solution. So standard solution is something that we know the concentration for sure. And for standard solution, we have to prepare something that is stable so it will not degrade over time. Also, it has to be non-hygroscopic, so it doesn't absorb water. So the mass will not change over time, so that's called non-hygroscopic. Non-hygroscopic. And normally we also prefer the compounds with high molar mass, so it is also easy to weight without introducing a lot of error. So in this case, we will add the base drop by drop to the acid solution, and over here we will have a reaction of acid-base reaction. And using this reaction, we will then be able to calculate, for instance, we know the volume of the base that we add. So over here we have Vb. We have to know the molar of the base. We also know the volume of the acid that we have in the beginning, and therefore, when it reaches something that is called as the equivalent point, so equivalent point, when it reaches the equivalent point, the mole of the acid will be equal to the mole of the base. The volume of the acid multiplied by the molarity of the acid will be equal to the volume of the base multiplied by the molarity of the base. And therefore, we can calculate the molarity of the acid by taking this value, divided it with the volume of the acid. So at equivalent point, we will have the exact mole or equivalent amount of acid with the mole or equivalent amount of the base. Now, normally we have a reaction between either strong acid and strong base, or weak acid with strong base, or weak base with strong acid. So now we'll take a look at the first example where we have HCl plus NaOH titration. So in this case, we have a strong acid, and then here we have a strong base. So I will write down here strong acid and strong base. So in this particular reaction, we will get the product of a salt. So here, notice that this is not an equilibrium reaction anymore. This reaction will be close to completed, so we can just write down one arrow to the right side. Okay, so here we will produce the salt of NaCl, of course, and H2O water. Now in this case, as you can see, we do not have anything that is colored. If you know the HCl solution, this is transparent. NaOH is also a transparent solution. Sodium chloride, if you make a solution of salt, obviously it's also going to be more or less transparent, so no color. H2O is water, so it's also transparent. So here basically we cannot tell whether the reaction has been completed, and therefore in the titration case we will add something that is called the indicator. So when it reaches the equivalent point, if we pick the right indicator, then the indicator will change in color. And based on that change in color, we can determine the end point of titration. A good titration, or a correct titration, will be where the end point is as close as possible to the equivalent point. Because actually this is what we would like to measure, and this is what we actually monitor. So the indicator has to be able to change color as close as possible to the equivalent point, and therefore we will get the end point of titration also as close as possible to the equivalent point. Now, With every titration, normally we will obtain something that is called the titration curve. In this HCl and NaOH titration, we will get something that looks similar to this. So in this case, if we have the y-axis being the pH of the solution, x-axis being the volume of the NaOH that we add to the HCl system. If we have acid in our beaker, therefore in the beginning we will start at low pH because we have acid. Vice versa, if we have base in the beaker, then we will start with a higher pH. So in this case, we will have that in the beginning. And then we add NaOH, so the pH will get higher and higher and higher, and at some point it's going to jump, and then it will look something like that. So the one here is called the equivalent point. So this is the equivalent point. The point or the pH where the mole of the acid is going to be exactly equal with the mole of the base. And for this system, normally the equivalent point will be achieved around the pH of 7. So we should pick an indicator that would change color around the pH of 7. And normally the example of indicator that is commonly used is called the phenolphthalein. It changes color from transparent to light pink when it reaches this kind of pH. So if we take a look at this titration, actually we have 3 different points. We can have the point A, so before equivalent point, and then we have the point B, which is at the equivalent point, and the point C. Let's take a look at each of the point. At the point A, so before the equivalent point, we have the reaction between HCl and NaOH forming NaCl and H2O. And in this case, before the equivalent point, we have a small amount of NaOH being added to HCl. So if we have X over here, we add Y of NaOH, where the Y will be smaller than X. Therefore, here it's minus Y, plus Y, and plus Y. So in this case, we will see that we will have X minus Y. Normally, for titration, always work with mole. Because for titration, we will add some solution into other solutions, so obviously we are going to change the volume, so it is risky to work with molarity, as molarity will be changed upon changing volume. So always work with mole when we perform titration studies. And this will be 0 because it will be the limiting reactant. This will be plus Y, and this will be plus Y. In this system, we have NaCl, and NaCl is a neutral salt, so this will not contribute to anything. The one that will influence the pH is this one, the HCl, which is X minus Y mole. And in this case, the pH will be minus log of X minus Y mole. Don't forget you have to use concentration, so you have to divide with the volume or the total volume in the beaker. So this is what happens at the point below the equivalent point. Now, next we have the B point, and this is the equivalent point. So again, the reaction is obviously going to stay the same. NaOH, and we have NaCl plus H2O. So here we have the same amount of acid and the base. This is what the equivalent point means. So if we have X over here, we also have X over there. So this is going to be consumed completely. So both of them will react with each other and be consumed completely. So here at this point, you will only have a salt, which is NaCl, and you also have H2O. And since NaCl is a neutral salt, so the pH has to be 7. And finally, you will have the point after equivalent point, so point C. Again, the reaction is exactly the same. Cl plus H2O. And in this case, you will have higher amount of NaOH. So now you would have added a lot of NaOH to the beaker. So if we have here x. Here we have z, for instance. Z is bigger than x, so this is minus x plus x plus x. So we'll get 0. So the HCl is now the one that is being consumed. We'll have this mole of NaOH. This is the salt, and that is the water. So in this case, the pH is going to be equal to the 14 minus POH, because POH is the one that we can calculate here. That is going to be equal to minus log of the OH minus Z minus X mole, don't forget, divided by the total volume inside the beaker. So from here, we will get that at this point, the pH will be high. At this point, the pH will be equal to 7, and at this point, the pH will be low. So that is what you get here. A point, pH is low. Normally, acid is dominant here. And then B is where you have only a neutral salt. Acid and base will both be consumed completely. And then you get C, where this is mainly just the base. Now, I would like you to try on your own to draw and interpret if we have first titration between a weak acid plus a strong base. What will we get? Second, if we have a weak base plus now a strong acid. So for this case, you have to write down or try to plot the titration curve. And then identify pH of A, which is before the equivalent point, at B, which is at the equivalent point, and at C, which is after the equivalent point. This one is before the equivalent point, B is at, and this one is after the equivalent point. We will discuss the solution in class.